This locomotive is not the largest steam engine ever built. It is not the most powerful. It is not the fastest. It is not the most innovative. And yet the Pennsylvania Railroad built 425 of them. More Pacific-type locomotives than any other American railroad ever built of a single class. They built 425 because what was under the hood was not extreme. It was optimal. 425 locomotives of essentially the same design served the Pennsylvania Railroad for more than 50 years. Some operated continuously from 1914 into the late 1950s. They hauled the most prestigious passenger trains in America. They never broke down catastrophically. They were never replaced because something better became available. This is what is inside a locomotive that achieved excellence through restraint, the steam engine that defined American railroad practice, not by pushing limits, but by mastering the conventional, the standard that defined an era. Every previous video in this series has focused on engineering extremes. The big boy pushed articulated steam to its maximum scale. The GG1 pushed electric power to its maximum durability. The EMDF unit pushed diesel-electric design to its maximum economic efficiency. The K4 Pacific is the opposite story. Conservative engineering choices, conventional design philosophy, no radical departures, no experimental subsystems, no theoretical performance ceiling. And the K4 is on this list precisely because of that restraint. The Pennsylvania Railroad designed the K4 to be the best possible expression of standard American Pacific practice. Every component was chosen for proven reliability rather than peak performance. Every system was optimized for maintenance rather than maximum output. What is under the K4's hood is a masterclass in industrial optimization. The locomotive that proves engineering excellence does not require engineering extremity. The K4's boiler operated at 205 pounds per square inch of working pressure. By the standards of 1914, when the design was finalized, this was conservative. The K4's contemporaries, Pacific locomotives built by other major American railroads, operated at boiler pressures ranging from 180 to 220 pounds per square inch. The Pennsylvania chose 205 pounds specifically because the firebox crown sheets, boiler tubes, and structural fittings of 1914 American manufacturing could be expected to perform reliably at that pressure for decades. Higher pressures would have produced marginally more power. They would also have required more frequent inspections, more expensive repairs, and shorter component lifespans. The firebox was the K4's most distinctive engineering feature. The Belpaire design, developed by Belgian engineer Alfred Belpaire in the 1860s, used a flat-top firebox with square corners rather than the rounded Wooten or wagon-top designs preferred by most American railroads. The Belpaire shape was more difficult to manufacture. It required additional structural stays. It was heavier than equivalent rounded designs, but it offered specific engineering advantages that made it ideal for the Pennsylvania's operating philosophy. The flat-top Belpaire firebox provided more uniform water circulation around the combustion chamber, which reduced thermal stress and extended the working life of the crown sheet. The square corners simplified the structural staying, which made inspection and maintenance more straightforward. The additional weight was acceptable because the K4 was designed for mainline service, where axle loading was not a critical constraint. The Pennsylvania Railroad standardized on the Belpaire firebox across virtually all of its steam locomotive classes. Every Pennsylvania steam engineer learned the same firebox geometry. Every Pennsylvania shop was equipped to maintain it. Every spare component fit every Pennsylvania locomotive. The standardization itself was an engineering advantage that no other American railroad replicated. The K4 used a Schmidt-type superheater, a system of large diameter tubes inside the boiler flue that took saturated steam from the boiler and reheated it to higher temperatures before delivery to the cylinders. The superheater was retrofitted to early K4s and built into later units as standard equipment. The thermal efficiency improvement was substantial. The mechanical complexity was modest. Like the boiler pressure, the superheater design was conservative. Other railroads experimented with more aggressive superheater designs that promised higher steam temperatures and greater efficiency. The Pennsylvania chose the proven Schmidt design and applied it consistently across the entire K4 fleet. The proven design worked. The aggressive alternatives often did not. The boiler made the steam, but the locomotive's character came from how that steam was used. And the choices the Pennsylvania made about the drivetrain were just as conservative as the boiler design. The K4 used two outside-mounted cylinders, each 27 inches in diameter, with a 28-inch stroke. The cylinder dimensions were modest by the standards of contemporary American Pacific locomotives. Some competing designs use larger cylinders to produce greater theoretical horsepower. The Pennsylvania chose the smaller cylinders deliberately. Larger cylinders required higher steam consumption, which strained the boiler at sustained high-power operation. The K4 cylinder dimensions were sized to match the boiler's sustainable steam generation capacity. The locomotive could maintain its rated performance continuously rather than producing peak output briefly and then exhausting its boiler. The valve gear was Walschaerts, a proven design developed in the 1840s and refined by every major locomotive manufacturer in the world. The Pennsylvania chose Walschaerts over the more sophisticated Caprati rotary, cam valve gear, or the experimental poppet valve, designs that some American railroads tried during the 1930s. Walschaerts valve gear had one defining advantage. It worked. Every railroad mechanic in America understood it. Every spare part could be machined at any properly equipped shop. The valve gear's behavior was predictable across the entire operating range. There were no surprises. The driving wheels were 80 inches in diameter. This wheel size was the standard for high-speed American passenger locomotives of the era. Larger wheels would have allowed higher maximum speeds at the cost of starting tractive effort. Smaller wheels would have improved starting but limited cruising speed. 80 inches was the optimum compromise. The Pennsylvania did not push for higher wheel diameters, even when competitor railroads experimented with 84-inch or 88-inch drivers. The 80-inch wheel was proven. It was manufacturable at every Pennsylvania shop. Spare tires could be cast at the Pennsylvania's own foundry. The economic advantages of standardization outweighed the marginal performance gains of larger wheels. The smokebox face carried the K4's most visually distinctive feature: twin cross-compound air pumps mounted symmetrically across the boiler front. These pumps provided the compressed air for the train's air brake system. Other American railroads mounted single pumps in less visible locations. The Pennsylvania mounted two pumps prominently. The dual pump arrangement provided redundancy. If one pump failed in service, the other could maintain air pressure long enough to reach the next servicing facility. The visible mounting allowed engineers and mechanics to inspect pump operation at every stop. The arrangement also gave the K4 its instantly recognizable face, a face that became inseparable from the identity of Pennsylvania Railroad passenger service. But the deepest engineering choice in the K4 was not the boiler or the drivetrain. It was the decision to make 425 identical locomotives. Most American locomotive classes during the 1910s and 20s were built in small batches, 20 or 30 units at a time, often with significant variations between sub-batches. Different cylinder dimensions, different valve gear arrangements, different appliance configurations. The Pennsylvania built 425 K4s over 14 years. The basic design did not change. Improvements were incorporated as field experience accumulated, but the fundamental architecture remained consistent from the first K4 in 1914 to the last in 1928. The result was operational and economic. Every Pennsylvania shop carried the same spare parts. Every Pennsylvania mechanic was trained on the same procedures. Every Pennsylvania engineer knew exactly how the locomotive would behave in any operating condition. The K4 was the Pennsylvania Railroad's universal language for passenger steam, and the Pennsylvania kept improving the K4 fleet throughout its service life. Feedwater heaters were retrofitted starting in the late 1920s. Equipment that recovered exhaust heat to pre-warm boiler feedwater, improving thermal efficiency. Mechanical stokers were added to allow the larger coal consumption rates required by heavier passenger consists. Modern lubrication systems were installed. Improved brake equipment was added. Cab modifications were made to reduce engineer fatigue. The K4 of 1950 was not identical to the K4 of 1914, but it was recognizably the same locomotive with the same fundamental architecture. operating on the same principles. The K4 hauled the Broadway Limited. It hauled the Congressional Limited. It hauled the General. It hauled every premier Pennsylvania passenger train through the steam era. When dieselization began in the late 1940s, the Pennsylvania kept K4s in service to supplement diesel operations. The class continued in service through the early 1950s. The last K4 was retired from regular service in 1957. The class had operated for 43 years. Some individual locomotives had run continuously for over 4 decades. The maintenance had been routine. The component replacement had been predictable. The performance had been consistent. No other American Pacific class achieved this kind of longevity in this kind of numbers. The K4 was not the most powerful Pacific. It was not the fastest Pacific. It was simply the Pacific that the Pennsylvania Railroad could operate reliably for half a century. The K4 became the visual and operational signature of Pennsylvania Railroad passenger service for more than 4 decades. The Pennsylvania Railroad itself ceased to exist in 1968 when it merged into Penn Central. The K4 outlived the conditions that produced it. 2 original K4s survive in preservation, number 3750 at the Railroad Museum of Pennsylvania and number 1128 at the Railroaders Memorial Museum in Altoona. Both are static displays. The K4 also achieved something no other American steam locomotive has accomplished. It became the official state locomotive of Pennsylvania in 1987. The legislature recognized the K4 specifically as a symbol of Pennsylvania industrial heritage. And in 2023, a heritage organization called the T1 Trust began construction of a brand new K4, number 5550, using the original Pennsylvania Railroad blueprints and engineering specifications. The new K4 will be the 426th K4 ever built, the first new K4 in nearly a century. The locomotive is so well engineered, so thoroughly documented, and so culturally significant that enthusiasts are willing to fund and execute a multi-million-dollar new construction project to put another one on the rails. The argument the K4 makes is not glamorous. It does not claim to be the most powerful. It does not claim to be the most beautiful. It does not claim to be the most innovative. It claims only to be the best possible expression of standard practice. The locomotive that did its job day after day, decade after decade, without drama and without compromise. Every locomotive in this What's Under the Hood series represents a different philosophy of engineering. The Big Boy pursued maximum scale. The GG1 pursued maximum durability through electric power. The F unit pursued maximum economic efficiency through diesel-electric design. The K4 pursued something different, maximum effectiveness through restraint. The locomotive that proves you do not need to push the limits to define an era. The K4's engineering legacy is not visible in modern locomotives the way the F units is. There is no modern descendant of the K4. The Pennsylvania Railroad designed the locomotive for its specific operating environment, and that environment no longer exists. But the philosophy survives. Every modern locomotive that achieves long-term success through conservative engineering choices, every diesel locomotive that runs for 50 years because its design avoided unnecessary innovation, every electric locomotive that endures because its architecture was built on proven principles rather than experimental ambition, descends philosophically from the K4. The argument that boring engineering is better engineering, the locomotive that mastered the conventional and outlasted everything that tried to surpass it. K4 Pacific is the final entry in our What's Under the Hood series. 4 locomotives, 4 different philosophies of engineering. The Big Boy pushing articulated steam to its maximum. The GG1 perfecting electric drivetrain durability. The EMDF unit ending the steam era through diesel-electric ubiquity. And the K4 proving that mastery of the conventional can define an era as thoroughly as any engineering extreme. If you have not watched the other 3 videos in this series, links are in the description. The 4 locomotives together tell the complete story of how mechanical engineering shaped American railroading. From the largest steam locomotive ever built, to the most durable electric, to the most economically transformative diesel, to the most operationally optimized conventional steam. Thank you for watching this series. There are more engineering deep dives coming. There are more locomotives that deserve to be examined for what is mechanically inside them, rather than what they look like on the outside. Subscribe so you do not miss the next one. American railroad engineering produced some of the most consequential mechanical designs of the 20th century. Most of them get celebrated for their appearances. We will keep examining them for what actually made them important.